Now, so today's class will be mainly numericals involved. Not only today's class, till we finish this chapter. There'll be a little bit of teaching part as well. New topic will also come in, but mostly teaching numerical. You remember last time I told you about stoichiometric calculations. Do you remember that?
Yes, sir.
Say yes or no. I started with that.
So you told about the coefficients of stoichiometric calculations, but that's it.
Okay. Okay. um, I'll take the same example again and remind you. Let us say methane gas bonds with oxygen to give CO2 gas and 2 water. Water is a liquid, remaining everything is a gas. Now, how can we visualize this equation? How do we think about this equation in different ways? What is the information conveyed by this equation? Because that information will be used for calculations. Any calculation based on balanced chemical equation, any calculation based on chemical equation is called stoichiometric calculation. See, I can say one molecule reacts with two molecules to give one molecule and two molecules of water. I can also say one mole reacts with two moles to give one mole and 2 moles of water. I can also say that now in terms of weight, 16 grams of methane, that is the molecular weight, reacts with 2 into 32, that is 64 grams of oxygen to give 44 grams of carbon dioxide, and we can also say 36 grams of water, right? These are different ways. We can also say in terms of volume, 1 mole of any gas at STP occupies 22.4 liters of volume, but that is only for gases. So I can say 22.4 liters of methane reacts with 2 into 22.4 liters of oxygen to produce 22.4 liters of carbon dioxide gas, right? Only for gases, will not consider water in this case because water is not a gas, it's a liquid. Now I'll share numericals one by one on WhatsApp and in the chat box also, of course, and we'll solve these numericals. Yes, you can see I've shared one numerical on WhatsApp. We'll solve this. This is numerical number 17. You'll find Intext Numerical-17 in the chat box of this video. We are starting with simple numericals. Gradually, numericals will be difficult. 6 grams of hydrogen reacts with hydrogen to produce oxygen to produce water. I'm writing equation 2H2 plus O2 gives 2 water. We'll proceed systematically so that it becomes easy for you. We are given 6 grams of hydrogen. Starting, N means number of moles. So starting moles of hydrogen, 6 divided by molecular weight, 3 moles. So we are starting with 3 moles of hydrogen reacted with oxygen to produce water. How much oxygen? That is not given. It means oxygen is taken in excess. Now question is A part. Calculate weight of oxygen consumed. Weight of oxygen consumed. See, how do we solve? This is 2 into molecular weight, 4 grams. And this is 1 into molecular weight, 32. I can say 4 grams of hydrogen will consume 32 grams of oxygen. 1 will consume 32 divided by 4. And 6 grams will consume. So there's no need of even moles. So 6 grams will consume how much? That is one answer. 48 grams of oxygen. B part. Calculate volume of oxygen consumed at STP. Volume of oxygen consumed. 2 moles means 4 grams. 4 grams will produce 1 mole means 22.4 liters. So 4 grams of hydrogen will consume 22.4 liters of oxygen. 1 will consume 22.4 divided by 4 liters of oxygen. 6 will consume how much? Let us rub this. 6 grams will consume how much? This will come out to 33.6 liters. Second answer. Third part is calculate weight of water produced. Weight of water produced will be 4 grams of hydrogen gives 36 grams of water. 4 grams of hydrogen gives 36 grams of water. 1 gives 36 divided by 4. 6 grams will give how much? So this will come out to 54 grams. These are 3 answers. Now, next numerical. There'll be numericals and numericals. As I said, they'll become gradually difficult. Look at this one. Is there on your WhatsApp? Okay. Numerical is aluminium reacts with dilute HCl to produce hydrogen gas while silver does not. A 16.2 grams alloy of these two metals contains 3.011 into 10 to the power 22 atoms of silver. Calculate the volume of hydrogen gas produced at STP when this sample of alloy is put in excess of dilute HCl. Now, first of all, we'll calculate the weight of silver present in this alloy. We are given number of atoms of silver, will convert into weight. So weight of silver will be, Avogadro number of atoms will be equal to atomic weight of silver. And atomic weight of silver is 108. So Avogadro number of atoms will weigh 108 grams. One atom will weigh 108 divided by whatever is the value of Avogadro's number. You know it very well. And 3.011 into 10 to the power 22 atoms will weigh how much? That you can calculate. So this will come out to 5.4 grams. It means alloy contains 5.4 grams of silver. Remaining is aluminium, which will react with HCl. So weight of aluminium will be 16.2 minus 5.4. This will come out to 10.8 grams. Now I'm writing the equation. 2 aluminium plus 6 HCl gives 2 AlCl3 plus 3 hydrogen. This is 2 into atomic weight 54 grams. Question is volume of hydrogen produced. Volume of hydrogen will be, look, 54 grams of aluminium will give 3 into 22.4 liters of hydrogen. 1 gram aluminium will give 2 into 22.4 divided by 54 grams, right? 1 gram will produce so many liters of hydrogen. And 10.8 will give how much? This will be the volume of hydrogen produced. This will be the answer, that is 13.44 liters, right? From the alloy, first calculate the weight of silver, subtracted, aluminium will be left. And this aluminium will react with HCl to produce hydrogen and will calculate volume of hydrogen produced. Next, third numerical. That was numerical, Intext Numerical-18. Now I'm sharing Intext Numerical-19 because you'll find all these numericals in your chat box of the video. There are two equations, two reactions involved. First, let me write these equations, then I'll explain. Sodium bicarbonate plus HCl gives sodium chloride plus CO2 plus water. Second is sodium carbonate plus 2HCl gives 2NaCl plus CO2 plus water. Now, numerical is a mixture of sodium bicarbonate and sodium carbonate contains total 10.8396 into 10 to the power 22 molecules. So total molecules are, we are given, we convert into moles. So total moles of these two, 10.8396 into 10 to the power 22 divided by Avogadro's number, right? This will come out to 0.18 mole. Reacts with dilute HCl according to these equations. If total 14.04 gram of NaCl is produced, calculate percentage of sodium bicarbonate in the mixture. This total NaCl produced, how much? Total moles will be 14.04 divided by molecular weight. Total 14.04 gram of NaCl is produced, divided by molecular weight, this will come out to 0.24 mole. So total moles of these reactants 0.18, total moles of NaCl produced by both the reactions is 0.24 mole. We have to calculate percentage of sodium bicarbonate in the mixture. Now, say NaHCO3 is equal to X mole. Therefore, sodium carbonate will be 0.18 minus X mole. Now, NaCl produced by these two reactions. 1 mole will give 1 mole. It means X mole will give X mole. Total NaCl produced. I'll repeat. 1 mole will give 1 mole. X mole will give X mole. 1 mole will give, second equation, 1 mole will give 2 moles of NaCl. 0.18 minus X will give double of this. So this will be 2 into 0.18 minus X. And this total is equal to 0.24. 0.24. I'll write on the top. Calculate the value of X. This X will come out to 0.12. X is 0.12 means number of moles of sodium bicarbonate is 0.12. Remaining is sodium carbonate. Therefore, weight of sodium bicarbonate will be number of moles 0.12 multiplied by molecular weight of sodium bicarbonate, that is 84. How much is that? I'll tell you. Weight of sodium carbonate. How many moles? 0.18 minus 0.12. 0.06 mole. Multiply by molecular weight 106. So weight of sodium bicarbonate will be 10.8 gram. 10.08 gram. And sodium carbonate will be 6.36 gram. Now, once we have masses of both reactants, we can add them. Total will be 16.44. Now, percentage of sodium bicarbonate will be sodium bicarbonate 10.08 divided by total 16.44 into 100. This is the percentage of sodium bicarbonate in the given mixture. So that's how gradually numericals will become difficult, right? It's not that there's anything out of syllabus. Everything is a part of the syllabus. The only thing is you have to solve more and more difficult numericals, then only subject will become interesting. Now we are starting with the next topic. Write down limiting reagent. Limiting reagent. Now, before I start the proper topic, just listen to my one or two examples carefully. Let us say there is a furniture workshop and they are making dining tables. In that factory, there's one section in which tables are being made. In the other section of the factory, chairs are being made. And they are making 6-chair dining tables. For every table, 6 chairs will be used. Let us say in one day, they make 4 tables. And in one day, they make they make 18 chairs, right? In one day, one section makes 4 tables, the other section makes 18 chairs. So by the end of the day, now think carefully and you have to answer me, by the end of the day, how many dining tables will be ready to be sent to the market for sale? Yes, please, I'm waiting.
Sir, it depends on the number of chairs which are present around it, right?
Yes, tell me how many dining tables, complete sets will be uh, ready for sale in the market?
So if it's a table of 6, then...
Yes.
Oh, okay. So if it's a table of 6, then...
Please. See, I'll tell you. 3 will be ready. 3 complete sets of dining table will be ready to be sold in the market. How do I decide? For one dining table, I need 1 table. Divide by 1. For one dining table, I need 6 chairs. Divide by 6. It means 16 chairs are sufficient for 3 dining tables. For 3 dining tables, I need 3 tables, but I have 4. It means all 18 chairs will be consumed. Out of 4, 3 tables will be consumed. 1 table will be left. That remaining table will be used probably the next day. So 3 dining tables, complete sets, 3 complete sets will be ready to be sold in the market. So which product, table or chair, which product decided how many dining tables will be ready to be sold in the market? Chairs, right? Chairs decided. So since chair decides the net product to be sold in the market, chairs will be called limiting reagent because chairs decide the limit of quantity of product which is ready. I'll repeat, number of chairs have decided the limit of quantity of product to be sold in the market. Therefore, chairs will be limiting reagent. I'll give one more example. Please be attentive this time. Let us say there is a car factory. There are different sections in that factory. In one section, engines are being made. In one day, they make 20 engines. In one section, body of the car, body, doors, and or everything that is being made. And in one day, they make 24 bodies. One section is for tires and the other is for tubes. They make, let us say, 80 tires in one day. Or I change the number, 60 tires in one day. And they make 100 tubes in one day. By the end of the day, when all these things are assembled, how many cars will be ready to be sold in the market? Let me tell you, how do we decide? How do we decide? For one car, we need one engine. So divide by one. For one car, we need one body. Divide by 1. 24. For one car, we need 4 tires. Divide by 4. For one car, we need 4 tubes. Divide by 4. 25. After dividing, whichever is the lowest number, that will be the number of cars which will be ready to be sold in the market at the end of the day. So 15 cars will be ready at the end of the day. It means tires have decided how much product will be ready by the end of the day. So tires will be called limiting reagent. Similarly, during a chemical reaction, see, why could 16th car not be made ready for market? Because we did not have more tires. That's why
Yes.
we had to stop the process of assembling. Similarly, during a chemical reaction, if one of the reactants is totally consumed during the reaction and other reactants are still present, reaction will stop, right? So that reactant which is finished in the, which is first to be finished, that will decide the quantity of all products formed during the reaction, and that will be called limiting reagent. And how do we decide limiting reagent? I told you, divided by something. Similarly, in case of chemical reactions, we'll divide number of moles of different reactants by their stoichiometric coefficients. That number, which is the least after dividing, that will be called stoichiometric amount. So least stoichiometric amount will be the limiting reagent. Gradually, as we proceed, this topic will be clear on the basis of numericals only. First, we write the definition of limiting reagent. Write down. It is that reactant which is taken in less quantity compared to other reactants as required by the balanced chemical equation. As required by the balanced chemical equation. Due to this, it is completely consumed during the reaction, after which reaction stops. Since such a reactant limits the quantity of various products formed, it is called limiting reagent. Thus, quantity of various products formed depends on limiting reagent. depends on limiting reagent. Next paragraph. To decide limiting reagent, number of moles of each reactant are divided by their respective stoichiometric coefficients. And the number obtained is called stoichiometric amount. That reactant whose stoichiometric amount is least is the limiting reagent. Check your WhatsApp message. I've shared one numerical. This is Intext number 20 in the chat box. And we'll solve this on the basis of limiting reagent. Starting with 8 grams of hydrogen and 80 grams of oxygen. I'm writing the equation. Hydrogen and oxygen will react to produce water. N means moles. Starting with 8 grams of hydrogen, 8 grams divided by molecular weight, 4 moles. And 80 grams of oxygen, 80 divided by molecular weight, 2.5. Naturally, there's no product in the beginning. So we started the reaction with 4 moles of hydrogen, 2.5 moles of oxygen. Question is, calculate mass of water formed and reactant left. Look here. First of all, we'll have to decide which of the two reactants is limiting reagent. Without writing, think in your mind and decide which is the limiting reagent. See, number of moles divided by stoichiometry. This will be 2. 2.5 divided by stoichiometry is 1. We'll get 2.5. I'll repeat. 4 divided by 2, 2.5 divided by 1. Whatever values we get, that is called stoichiometric amount. In which of the two cases stoichiometric amount is lower or the least? Hydrogen. It means hydrogen is limiting reagent. Below this, write down LR, limiting reagent. This will be completely consumed during the reaction. As you remember, limiting reagent were tires in that factory. Tires were completely consumed, and therefore 16th car could not be assembled. Now, number of moles consumed. Limiting reagent, you can blindly write, it will be completely consumed. 4 out of 4 moles will be consumed. Now, think carefully, listen carefully. Now, calculation will be on the basis of stoichiometry and limiting reagent. 4 moles will consume 1 mole. I'll go a bit slow so that because this is the first numerical for you. 2 moles of hydrogen will consume 1 mole of oxygen. 4 will consume how much? 2 moles. I'm starting with limiting reagent. I did not say 1 mole will consume 2. Rather, I said 2 moles will consume 1 because hydrogen is limiting reagent. So 2 moles will consume 1 mole of oxygen. 4 moles will consume how much? 2 moles. This side. 2 moles of limiting reagent. 2 moles of limiting reagent will give 2 moles of water. 4 moles will give 4 moles of water. right? So I can say consumed oblique formed. In this step, I've calculated how many moles are consumed, how many moles are formed. Now, final number of moles. Reactants will be initial minus final. 4 minus 4, 0. 2.5 minus 2, 0.5 mole of oxygen is left. Product, in case of product, it will be final minus initial. Final, we have 4 moles. Initial was 0. 4 minus 0, 4 moles. Now, it means after the reaction, weight of oxygen left 0.5 mole into molecular weight. 16 grams of oxygen will be left after the reaction. Second, weight of water formed. 4 moles of water is produced. 4 into molecular weight, 72 grams of water is formed. These are two answers. And we can even cross-check whether our answer is correct or not. We can cross-check on the basis of law of conservation of mass. See, we started with 8 plus 80. We started with 88 grams of reactants. After the reaction, 88 grams is not the product, but total mass of product formed and the reactant left, that should be equal to starting mass, that is 88. You can see 16 plus 72, 88 grams is the mass of products formed plus reactant left, right? That's how we'll calculate. This was easy one. Gradually, some difficult numericals will be there. We'll solve one more. Check your WhatsApp message. This is on combustion of methane. Let me write the equation first. Methane plus 2O2 gives CO2 plus 2 water. This is the balanced chemical equation. Except water, all other reactants and products are gases. Now, 56 grams of methane. Starting moles. 56 divided by molecular weight of methane is 16, 3.5 mole. And 160 grams of oxygen. 160 divided by molecular weight of oxygen is 32. This will be 5 moles. So we started with 3.5 moles of methane, 5 moles of oxygen. First of all, which of the two is limiting reagent?
Oxygen.
Think yourself and tell me.
Oxygen.
Oxygen. This divided by 1, 5 divided by 2. 5 divided by 2 will be lower value. This is the limiting reagent. So remember, every calculation will be based on oxygen. Question is, calculate the amount of each product formed and the reactant left. Number of moles consumed and formed. This will be completely consumed. 5 out of 5 gone, consumed. Now, we'll start with the limiting reagent. 2 will consume 1, 5 will consume 2.5. 2 will produce 1, 5 will produce 2.5. 2 will produce 2, 5 will produce 5. Tell me, is that okay?
Yes, sir.
Now, Ria, is that okay?
Yes, sir.
Okay, good. Now, final number of moles. In case of reactants, I said initial minus final. 3.5 minus 2.5, 1 mole. 5 minus 5, limiting reagent will be completely consumed. Product, final minus initial. This minus 0, 2.5. This minus 0, 5. Now, weight of methane left. 1 mole into molecular weight. 16 grams of methane is left. That is one answer. Weight of CO2 formed. 2.5 mole into molecular weight 44, 110 grams. Weight of water formed. 5 moles into molecular weight is 18, 90 grams. These are 3 answers. Let us check our answer. It is correct or not. We started with this plus this. How much? 216 grams. 216 grams was the total mass of reactants. After the reaction, this plus this plus this, if you add, that is also 216. It means according to law of conservation of matter, these answers are correct. So we'll stop here because we have to discuss something. Then we'll wind up.